These are your notes on the introduction and reminder about atomic theory, as well as a reminder about the people that were important in discovering the atomic theory and creating the atomic theory. So the modern concept of the atom was born out of a series of theories and laws that were proposed in the 17 and 1800s, and it took a lot of steps to get to where we are today, so we're going to kind of talk about a few of those. So the first early observation was that we had the law of definite proportions, and that chemical compounds always contain the same elements in the same proportions. We also have the law of multiple proportions, and those two kind of go together because the law of multiple proportions tells us that elements always combine in ratios of small whole numbers, and so we know that they combine in ratios of small whole numbers in the same proportions when you're creating a compound. And then the last early observation was the law of conservation of mass, telling us that matter is never created nor destroyed. So those are some three important early observations that were made about the atomic theory. This is just a picture representation of the law of multiple proportions, just showing you things are going to combine in whole number ratios. So NO is a ratio of 1 to 1, and then NO2 is a ratio of 1 to 2. So the law of multiple proportions helps us with that whole number ratio and where it always combines like that. Dalton's atomic theory, so Dalton was really critical in figuring out different parts of the atom and figuring out the theory behind it, so he gave us some steps in the theory. So Dalton told us that all matter is composed of small particles called atoms, and that he also told us that atoms of a given element are identical in size, mass, and other properties. Atoms of different elements differ in size, mass, and other properties. So that was in the 1800s. The fact that matter is composed of small particles called atoms are still true, but one exception to the rule for number 2 on his atomic theory is that we know that atoms can vary in mass because we can have isotopes, and we'll talk more about isotopes when we talk about atomic structure. So Dalton also told us that the different elements combine in simple whole number ratios to form chemical compounds, and that in chemical reactions, atoms are combined, separated, or rearranged. Those are 3 very important terms that you need to know in chemical reactions. We know that when atoms combine in simple whole number ratios, this is the law of definite composition, so that's an important thing to note. Another part of his theory told us that atoms cannot be divided, or that atoms cannot be created or destroyed. Atoms actually can be divided into protons, neutrons, electrons, and quarks, and we'll get to what quarks are at the end. And we know that atoms cannot be created or destroyed based on the conservation of mass and of energy. So that's essentially Dalton's atomic theory. When we talk about atoms and when we talk about elements on the periodic table, please note that chemical symbols are the shorthand name for the element, and it's really important how you watch them. So some people that have really terrible handwriting need to be careful when we're writing chemical formulas and when we're writing chemical equations, because C, little little o is cobalt, big C, big O is carbon and oxygen. And so you've got to be careful and make sure that you're being really deliberate in terms of writing these chemical formulas correctly. Big N, little I is nickel, big N, big I is nitrogen and iodine. So again, watch how you are writing things. What are the subatomic particles in an atom? So these are the important characteristics of the particles and their mass. So proton, neutron, and electron, this should be a review. We know that the proton is a P plus symbol, neutron is an N, and electron is an E minus symbol. The charge on a proton is a +1, the charge on a neutron is 0, and the charge on an electron is -1. We know that the mass of a proton is 1, and the mass of a neutron is 1, and the mass of an electron is negligible, very, very, very small. A guy named Millikan was actually the one that found out the mass of the electron, and it's very small, so it doesn't have anything really to add to the atomic mass, but we know that electrons are negatively charged subatomic particles located outside the nucleus and actually, in fact, make up most of the volume of that atom. We know that protons are subatomic particles of the nucleus, and they have a positive charge, and we know that neutrons are electrically neutral subatomic particles located in the nucleus. So again, this should just be a basic review of our subatomic particles. Another person that was important in developing the atomic theory was J.J. Thomson, and J.J. Thomson used a cathode ray tube to discover that light was made of negatively charged particles and electrons. So what he was able to do was bend light in the presence of a magnet. So I have a better picture on this slide here where showing here's my light ray, and when we produce a magnet here, we can bend light to either go towards the magnet or away from the magnet depending on which side of that magnet is there. So I'm assuming, based on it's going towards the magnet, that that's a positive and then that's a negative, so that they're going towards each other. If it were flipped, that light would go down the other way. So J.J. Thomson was a big component of helping us figure out that electrons were negatively charged. Another important person in the atomic theory discussion and evolution was Rutherford. Rutherford discovered that there was a dense nucleus. He discovered it via a gold foil experiment, which I'll show you on the next slide. And what he did was shoot high energy particles at this gold foil. And what he noticed was that as he was shooting these particles through, these electrons through, he thought that the electrons would just pass through. But what he proved actually was that there was a dense nucleus, so only a few actually bounced back. There was a dense nucleus, but that most of the atom was made up of empty space. So that's a really important discovery that he made. So this is the actual experiment here, where he's shooting these alpha particles through the gold foil, and he's assuming that they were all just going to go right through and hit straight. Most of them did, but there was enough that deflected off that he was able to, here's a good picture of deflection, right? That he was able to show that the atom does have a dense nucleus. So how does the nucleus stay together? Protons don't want to be close as they repel each other, but there's a strong force called the nuclear binding energy that holds all those positive protons very close together. So the nuclear force is greater than the electrostatic force. The two regions of the atom are the nucleus, so it is positively charged. It's very small, but it's very dense. It holds most of the atom's weight, and it's the central portion of the atom. And then we have the electron cloud, and this is what I was referencing before. So the electron cloud is negatively charged and takes up most of the atom's space, but it is mostly empty space, as electrons are very small. The cloud area is actually 10,000 times bigger than the nucleus. So our volume comes from the electron cloud, our mass comes from the nucleus. Niels Bohr is another important person in the atomic theory. He developed a model for the atom, and we'll actually learn a little bit later in this unit how to write a Bohr model. But he just talked about how electrons are in orbit around the nucleus, and how we have an electron cloud, so we can kind of show where electrons are in that orbit. And so we'll again dive into this a little bit further, but this should be a review from physical science. So a review of our progression. So we know that Dalton told us everything is made up of atoms. J.J. Thomson told us that atoms have negatively charged electrons. Rutherford told us that atoms have a nucleus that is a positively charged mass, but that the atom is made up of mostly negative empty space. And that Bohr told us that electrons surround the nucleus in distinct orbitals. And hopefully you're like, well, what's an orbital? We're going to get to that a little bit later. We're going to learn exactly what an orbital is. I told you I'd get to quarks, so what are quarks? Quarks were discovered in the 60s and 70s, and there's 3 families of quarks, and each family contains 2 quarks. And essentially what this is it helped figure out the overall charge of a particle in the atom. So the first family is an up and a down, and 3 of them join to form a proton or a neutron. So an up charge is a positive 2/3, and a down charge is a negative 1/3. So a proton combines to form a positive charge with the up-up-down quark, and then a neutron forms a 0 charge. So it's just important that these exist. That's basically all I'm going to ever talk about them, is just that you know what they are, and that it helped us figure out what the charges on the subatomic particles were. Okay, thanks for watching this video and filling in your notes.